Hello everyone, today I am going to teach second order derivative, that is exercise 5.7. So let's start. The question number 1 is y is equal to x square plus 3x plus 2. So here d by dx of y is equal to d by dx of x square plus 3 outside d by dx of x plus d by dx of 2 because there is no variable here. Fine. Now d by dx of x square is 2x. Plus dx get cancelled, so you are remained with 3 plus d by dx of 2, that is nothing but constant, so it is 0. So second order derivative means whatever the answer you have got, one more time you need to differentiate that. So if you differentiate this, again you will get a d square upon dx square of a y is equal to, write these two outside, d by dx of x plus d by dx of 3. Okay, dx cancel, so the answer is 2 here, plus d by dx of constant is 0. So 2 plus 0 is 2. So this completes your first answer. Right. Second one is y is equal to x raised to 20. Now d by dx of y so is equal to d by dx of x raised to 20. According to the formula 20x 20 minus 1. Okay. Now second order means you need to differentiate whatever the answer you have got. So it is d square upon dx square of y is equal to this 20 I have written here, d by dx of 20 minus 1 is 19. So x raised to 19 is equal to 20. Now this 19 x raised to 18, that is 19 minus 1. Now if you multiply 20 into 19, you will get 380 into x raised to 18. Fine. Now third question is y is equal to x cos x. As you know that this is the product rule. So what is the product rule? D by dx of y is equal to, keeping x outside, d by dx of cos x plus cos x d by dx of x. Fine. Now x as it is, d by dx of cos x is minus sin x plus write cos x as it is, dx get cancelled. Fine. Now for second order, whatever the answer you have got, so again you need to differentiate. So it is d by dx square. D by dx square of a y is equal to, take this minus outside, so this will become u and sin x will become v. So again product rule, x d by dx of sin x plus sin x d by dx of x plus for this one d by dx of cos x. So minus as it is, x as it is, d by dx of sin x is cos x plus sin x as it is, dx and dx get cancelled, plus d by dx of cos is minus sin. Fine. Now take this minus sign inside this. So minus x cos x minus into plus is minus, minus sin x will become minus 2 sin x. So this completes your third answer. Now let us move on to the fourth one. So y is equal to log x. So d by dx of y is equal to d by dx of log x. Now d by dx of log x is, according to the formula, it is 1 by x. Now again we need to differentiate this. So d square upon dx square y is equal to, when this x goes to the numerator, so it will become d by dx of x raised to minus 1. Now according to the formula, it is minus 1 x raised to minus 1 minus 1. So let me write the formula here. Formula is d by dx of x raised to n is n into x raised to n minus 1. So in place of n, it is minus 1. So minus 1 minus 2 minus 1 will become minus 1 x raised to minus 2 is equal to minus 1. This minus 2 will come in the denominator. So it is minus 1 divided by x raised to x square. Okay. Let us move on to the fifth sum. Now fifth question is y is equal to x cube log x. So this will become u and this will become v. So again we need to apply product rule. So d by dx of y is equal to x cube d by dx of log x plus log x d by dx of x cube. So this is by product rule formula. So I will write x cube as it is. D by dx of log x is 1 by x log x, d by dx of x cube is 3x square. Okay, this x and 1x get cancelled, so you are remained with the x square plus, let me write this here, into log x. Now I'll take common. So common is x square. So you will get x square 1 plus 3 log x. Now this will become u and this will become v, because we need to find d square y upon dx square for second order derivative. So this I'll write x square d by dx of 1 plus 3 log x plus 1 plus 3 log x and d by dx of x square. Okay, so x square, since 1 is a constant, so it will become 0 plus 3 d by dx of log x is 1 by x plus write this as it is, and d by dx of x square is 2x. Fine. Now what I am going to do is x square. Now 3 ones are 3, so 3 by x plus multiply this, 2 into 1 is 2x plus 3 2s are 6x log x. So I will cancel this x and this x. So what you are remained? You are remained with the 3x plus 2x plus 6x log x. Now add these two. If you add, you will get 5x plus 6x log x. So this is your final answer. Okay, let us move on to the sixth sum. Here this is u and this is v. Again we need to solve by product rule. So dy by dx is equal to e raised to x d by dx of sin 5x plus sin 5x d by dx of e raised to x. Okay, now e raised to x d by dx of sin 5x is 5 cos 5x. Whatever the number will be here, you need to write here. So it is 5 cos 5x plus sin 5x d by dx of e raised to x is e raised to x itself. So what is common in this? Common is e raised to x. So you are left out with 5 cos 5x plus sin 5x. Okay, so I need to find one more time derivative of this. So that will become d square y upon dx square. So this is only called as second order derivative. So this will become u and this entire term will become v. Again I need to apply product rule. So it is e raised to x d by dx of 5 cos 5x plus sin 5x plus 5 cos 5x plus sin 5x and d by dx of e raised to x. Okay, now e raised to x, now write 5 as it is, d by dx of cos 5x is minus 5 sin 5x. Okay, plus d by dx of sin 5x is 5 cos 5x plus I'll write as it is plus sin 5x d by dx of e raised to x is e raised to x itself. Now look at very carefully. Here also e raised to x, here also e raised to x. So I'll take common. It is e raised to x. 5 5s are 25. Minus 25 sin 5x and plus sin 5x. So 25 minus 1 is 24. So since it is a bigger number, so I'll write minus 24 sin 5x. Okay, plus 5 cos 5x and plus 5 cos 5x. 5 plus 5 will become 10 cos 5x. So this completes your sixth sum. Now eighth question is y is equal to tan inverse of x. So dy by dx is equal to d by dx of tan inverse of x. So that is 1 divided by 1 plus x square is the formula. So again d square upon dx square y is equal to d by dx of what I am going to do is I am going to take this on the numerator part, x square raised to minus 1. So as you know the formula of this, so it will become minus 1 plus x square minus 1 again by chain rule. By chain rule it will become d by dx of 1 plus x square. So minus 1 minus 2, that I will write in the denominator part. Okay, d by dx of 1 is 0 and d by dx of x square is 2x. So 2 ones are 2. So minus 2x divided by 1 plus x square is your answer. Okay, so let us move on to the ninth sum. Here dy by dx is equal to d by dx of log x. Consider this whole term as a one variable. So what is d by dx of log x? It is 1 by x. Since it is a chain rule, so I am going to write d by dx of log x. So 1 by log x into d by dx of log x is 1 by x. Again I have to differentiate this. So d by dx of x square is equal to d by dx of, I will write like this, raised to minus 1, same like here. So what will be the formula? It will become minus 1 x log x minus 1 and d by dx of x log x. So this will become u and this will become v. I need to apply product rule for that. So minus 1 I will write here and this will become x log x square, because minus 1 will become 2 and when it goes to the denominator part it will become positive. Now I need to write product rule here, x d by dx of log x plus log x d by dx of x. Okay, minus 1 x log x whole square, x d by dx of log x is 1 by x plus log x, this and this get cancelled. So if I cancel this x and this x, so I will remain with minus 1 plus log x whole divided by x log x whole square. Okay, this completes your ninth question. So let us move on to the next question. So the 10th question is y is equal to sine log x. So dy by dx is equal to d by dx of sine log x. Consider this as a whole one variable. So dy by dx of sine is cos log x. This is called as chain rule. So again you need to differentiate this log x. So you will get cos log x and d by dx of log x is 1 by x. So this can be written as cos log x upon x. So this is, you need to consider this as a u and this as a v because it is a quotient rule. Okay, so for second order derivative, so this x will become x square and I'll write this x here and d by dx of cos log x minus cos log x and d by dx of x. Okay, so x d by dx of cos is minus sine log x, again by chain rule d by dx of log x minus cos log x. This and this get cancelled. Fine. Whole divided by x square. So minus x sine log x d by dx of log x is 1 by x minus cos log x divided by x square. This x and this x get cancelled. So the final answer will be minus sin log x minus cos log x divided by x square. So let us move on to the 11th question now. So dy by dx is equal to, write this phi outside, dy by dx of cos x minus 3 dy by dx of sin x. Okay, 5 dy by dx of cos is minus sin x, minus 3 dy by dx of sin x is cos x. Take this minus outside, 5 sin x plus 3 cos x. Okay, again you need to differentiate this, because here we have to prove d square y upon dx square. Okay, so again I will differentiate, minus outside 5 d by dx of sin x plus 3 d by dx of cos x. So minus 5 d by dx of sin is cos plus 3 d by dx of cos is minus sin x. Now here you can see this, it is same like y, the given question. So what I can write, this minus I'll write as it is. Okay, this whole term is nothing but y, so I'll write here y. So d square y upon dx square. Take this minus y on the left hand side, so it will become plus y is equal to 0. So this is what we have to prove. I hope you understood this. Let us move on to the 12th question. Here 12th question is y is equal to cos inverse of x. Take this cos inverse on the left hand side, it will become cos y is equal to x. So let me differentiate this. D by dx of cos y is equal to d by dx of x. This and this get cancelled, and this will become minus sin y dy by dx is equal to 1, because dx has cancelled, so we have got 1. So dy by dx is equal to 1 divided by minus sin y. As you know that 1 divided by sin is cosec y. So this minus comes here. Again I need to differentiate this, because the given question is find d square y upon dx square. So this will become d square y upon dx square. So minus d by dx of cosec y. And the formula for cosec y is cosec into cot. Cosec into cot y dy by dx. Okay, so minus cosec y cot y. What is dy by dx? It is again minus cosec y. So minus into minus will become plus, cosec into cosec will become cosec square y into cot y. This completes your 12th answer. So let us move on to the 13th question. So it is y is equal to 3 cos log x plus 4 sin log x. So I need to show that x square y2 plus x y1 plus y is equal to 0. So y. So d by dx of y is equal to 3 d by dx of log cos log x plus 4 d by dx of sin log x. Okay, dy by dx can be written as y1. It means first derivative. Okay, so here 3 d by dx of cos is minus sin log x. Again by chain rule, d by dx of log x is, it is 1 by x. So directly I will write here divided by x plus 4 d by dx of sin is cos, and by chain rule d by dx of log x is, again it is 1 by x, so I will write like this. Okay, here if you take LCM, so x, right? So cross multiply here, so it will become x y1 is equal to minus 3 sin log x plus 4 cos log x. Fine. Again I need to differentiate this. So this will become u and this will become v. So by product rule, x d by dx of y1 plus y1 dx upon dx minus 3 d by dx of sin log x plus 4 d by dx of cos log x. Okay, so here I am going to write x d by dx of y1 will become y2. Fine, dx get cancelled, so you are remained with y1 is equal to minus 3 d by dx of sine means it is cos log x. Since it is a chain rule, so d by dx of log x is x, so it is 1 upon x, so I have written like this here. Okay, plus 4 d by dx of cos is minus sine log x. As you know that d by dx of log x is 1 by x, so I write here in the denominator part. Fine. Now again I need to take LCM. Since these denominators are same, I am going to multiply, means this x I am going to multiply here. So I will write here x cross multiplying. So this whole term again I am going to write here. Now I am going to take common. Common is minus. Here also it is minus. Here also it is minus. So 3 cos log x plus 4 sin log x. Okay, so x into x, it is x square, y2 plus x into y1, so it is, so minus this whole term you can see in the given question, it is y. So it is minus y. So finally you have to take this minus y on the left hand side, so you will get this. That is x square y2 plus xy1 plus y is equal to 0. So this completes your 13th answer. So let us move on to the 14th one. Your 14th question, y is equal to a e raised to mx plus b e raised to nx. Show that d square y upon dx square minus m plus n dy by dx plus mn into y is equal to 0. So first I am going to differentiate this. dy upon dx, a outside, d by dx of e raised to mx plus b d by dx of e raised to nx. So as per the formula of e raised to x, d by dx of e raised to mx is m into e raised to mx plus b n into e raised to nx. So I have got dy by dx now, means this one. So I need to differentiate one more time. So that is d square y upon dx square. So am d by dx of e raised to mx plus bn d by dx of e raised to nx. Fine. Now am d by dx of mx is m e raised to mx plus b n into e raised to nx. Now multiply this. M into m is m square plus b n into n is n square. Now what you do is write this given equation here. So given d square y upon dx square minus m plus n dy by dx plus mn y is equal to 0. So let us substitute the values. So d square y upon dx square is here. So I have to write a m square e raised to mx plus b n square e raised to nx over minus m plus n dy by dx. So what is dy by dx here? It is a m e raised to mx plus b n e raised to nx plus mn. I am going to write here y. What is y? Y is the given question. That is a e raised to mx plus b e raised to nx. Fine. Now write this as it is. M into m, it is m square. So a m square e raised to mx. Okay. Minus into plus is minus b mn e raised to nx minus m into n is a mn e raised to mx. So minus into plus is minus, n into n is minus b n square e raised to nx, plus multiply this a mn e raised to mx plus b mn e raised to nx. Here you can just check, all these get cancelled. One is plus, one is minus, one is plus, one is minus. If all get cancelled, so the final answer is 0. So I hope you understood this sum. Fine. So let us move on to the 15th question. So the question is, y is equal to 500 e raised to 7x plus 600 e raised to minus 7x. You need to show that d square y upon dx square is equal to 49y. So let us differentiate this. So dy by dx is equal to 500 d by dx of e raised to 7x plus 600 d by dx of e raised to minus 7x. So 500, as I have solved here m and n values, same type. Here the number is 7. So 7 e raised to 7x plus 600 minus 7 e raised to minus 7x. Fine. Now I need to differentiate one more time since I want this one. So d square y upon dx square is equal to 500 into 7. Now d by dx of e raised to 7x plus 600 minus 7 d by dx of e raised to minus 7x. Okay, 500 into 7, so this will become 7 e raised to 7x plus 600 minus 7, and this will become minus 7 e raised to minus 7x. Fine. So what I am going to do here is I am going to take common. What is common? Look at very carefully. 7 7s are 49 and 7 7s are 49. Minus into minus will become plus. So 49 is your common term. So 49, what is remaining? 500 is remaining. E raised to 7x plus 600 is remaining. E raised to minus 7x. Fine. 49. This whole term you can see in the given question, it is y. So finally we have proved that d square y upon dx square is equal to 49y. Fine. So let us move on to the next question. So 16th question is e raised to y into x plus 1 is equal to 1. You need to show that d square y upon dx square is equal to dy by dx whole square. So this is the product rule because this is u and this is v. So what I am going to do is e raised to y d by dx of x plus 1 plus x plus 1 and d by dx of e raised to y is equal to d by dx of 1. Fine. Here e raised to y dx get cancelled, so it is 1. Constant is 0 plus x plus 1. This will become e raised to y dy by dx because since the variable is y here, and d by dx of constant is 0. So this e raised to y I am going to shift on the right hand side, so it will become minus. Okay, so it will become e raised to minus e raised to y because 1 plus 0 is 1 and e raised to y will become e raised to y itself. When it is shifted on the right hand side, it will become minus. Directly this and this get cancelled. So dy by dx is equal to minus 1 is left out here and this will become in denominator. Now I need to differentiate this one more time. D square y upon dx square. So minus d by dx of x plus 1. So since it goes to the numerator, it will become minus 1 here. So minus 1. Okay. So this will become x plus 1 raised to minus 1 minus 1. Now again chain rule. Fine. So here minus 1, minus 1 will become minus 2. So when it comes to the denominator, 1 plus x square, and dx get cancelled. Okay, so it is 1, and d by dx of 1 is constant 0. So this is nothing but minus 1 divided by x plus 1 whole square. Now you can see dy by dx almost same. Okay, so this minus here outside, this minus will become plus. Fine, so this will become plus here. Now you can see if you square this, you will get the answer. So that is nothing but dy by dx whole square. So this is dy by dx, it is minus 1 divided by x plus 1. If you whole square you like this, then you will get minus as a positive, and x plus 1 will become x plus 1 whole square. Hope you understood this. Let us move on to the 17th sum. Okay, y is equal to tan inverse of x square. Show that x square plus 1 whole square, y2 plus 2x, x square plus 1 y1 is equal to 2. So this one, d by dx of y, d by dx of tan inverse of x whole square. So here I'll apply this formula. That is nothing but n into x raised to n minus 1. So here I am going to write 2 tan inverse of x d by dx of tan inverse of x. Now dy by dx is considered as a y1. Okay, so y1 is equal to 2 tan inverse of x, d by dx of tan inverse of x is 1 plus x square. This is the formula. Now cross multiply this. This cross multiply here. So you can also write 1 plus x square can be written as like this also. Okay, so 2 tan inverse of x. Now this will become u and this will become v. Again product rule. X square plus 1 d by dx of y1, y1 d by dx of x square plus 1, 2 into d by dx of tan inverse of x. Now this you need to write as it is. Always remember d by dx of y1 will become y2 plus y1 d by dx of x square will become 2x, d by dx of constant is 0, and 2 d by dx of tan inverse of x already I have written here, that is 1 divided by 1 plus x square. Now what you have to do is cross multiply. If you cross multiply this here, you will get the final answer. So therefore x square plus 1 whole square y2, multiplying this with this, okay, plus 2x plus 0 is nothing but 2x. I am going to write this y1 here, and since I am multiplying this side, so it will become x square plus 1 is equal to 2 ones are 2. So that is your final answer. This completes your entire exercise. Hope you understood this perfectly. Thank you very much for watching, and keep watching the other videos for more understanding the problems.